Hi viewers, this is J. Swami, Assistant Professor of Zoology. In this class we are going to discuss the male and female hormones. Under this topic, we see the introduction to the male and female hormones, hormonal action on testis, hormonal action on ovary, hormonal control of ovarian and menstrual cycle in humans, menstrual and estrous cycle differences, otherwise menstrual versus estrous cycle. Here, in man and other higher animals, the reproductive process are under the control of hormones. Reproductive hormones, they are very useful and they play an important role in both the sexes throughout the life. If you observe the early fetal development, in this stage, hormones play a key role in the sexual differentiation. Whereas if you come to the teenage, here the hormonal changes give rise to the puberty. The hormones secreted by the hypothalamus, pituitary, gonads, in the sense testis and ovary, and placenta, they play important role in the reproduction. Some extent, adrenal glands also influence the reproductive behavior of the human beings. The hormones may be amines, peptide, or steroids. They play a major role in the primary and secondary sexual characters development. Let us start with the hypothalamus. Hypothalamus, it is a chief regulator of the reproductive system. It produces two kinds of hormones. Hypothalamus produces two kinds of hormones, releasing hormones and releasing inhibiting hormones. If hypothalamus produce releasing hormones, thereby the anterior pituitary gland get activated and that releases some gonadotrophins. If the hypothalamus produces releasing inhibiting hormones and thereby the anterior pituitary may not be get activated and it is not supposed to produce these kind of gonadotrophins. So hypothalamus, that is a chief regulator and controls the entire reproductive hormones of the male and the female. Here if you observe one by one male and female hormones, here gonadotrophin releasing hormone released by the hypothalamus, it acts upon the anterior pituitary gland and stimulates the gland to produce FSH and LH, follicle stimulating hormone, and the luteinizing hormone. The target of the follicle stimulating hormone and luteinizing hormone is the testis, gonads of the male reproductive system. This FSH act upon the Sertoli cells of the seminiferous tubules and LH act upon the Leydig cells, otherwise interstitial cells. So that the LH is also known as the interstitial cell stimulating hormone. Interstitial cell stimulating hormone. Now these Sertoli cells, whenever get activated by the FSH, they go for the spermatogenesis, production, spermatids, production of the sperms. Whereas the Leydig cells, they produce the testosterone. It is the principal androgen, male reproductive hormone by the mature testes. If you observe the female reproductive system, same hypothalamus produce gonadotrophin releasing hormone that act upon anterior pituitary, that produces the luteinizing hormone and the FSH, follicle stimulating hormone. Follicle stimulating hormone interact with the Graafian follicle and helps to develop the ova, egg, and LH it useful for the ovulation. So here also the target organs are the female gonads. Female gonads. Now if you observe furthermore, so the hormones, they are useful in the fetal development, in the adolescent stage, and as well as in the adulthood of the male and the female. Male and the female. And also they are useful to make development of the secondary sexual characteristic features at the puberty of male and female. Come to the hormonal action on testis. Hypothalamus that secretes gonadotropin releasing hormone that interact with the anterior pituitary gland and produce the follicle stimulating hormone and luteinizing hormone. Follicle stimulating hormones, they interact with the Sertoli cells of the seminiferous tubules and facilitates the spermatogenesis. Whereas the luteinizing hormone that interact with the Leydig cells and that produces the testosterone hormone. And now, if you see the hormonal control, how these hormones control the release of the testosterone and release of the sperms from the testis, spermatogenesis, we will see. Here, the Sertoli cells, whenever the spermatogenesis is enough, during that time, they produce inhibin hormone that show negative feedback on the anterior pituitary and stops both the LH and FSH secretion. On the other hand, testosterone, it shows negative feedback on both the hypothalamus and stops the GnRH production, and also it interacts with the anterior pituitary, shows its negative feedback upon the anterior pituitary and stops the secretion of LH and FSH. That is, due to the negative feedback mechanism, the LH and FSH are temporarily stopped, and thereby there is a stop of spermatogenesis and the testosterone. The same thing here you can observe. GnRH, anterior pituitary, FSH and LH. FSH stimulates Sertoli cells that produces spermatogenesis. If it is enough, they produce inhibin and shows the negative feedback on the anterior pituitary. FSH and LH will be stopped. And this LH interact with the Leydig cells, produces testosterone, and this testosterone shows negative effect on both the hypothalamus and as well as the anterior pituitary gland. Like this, there is a hormonal control on both the hypothalamus and the anterior pituitary gland. Here, the testosterone plays a major role. It is very, very important androgen, male reproductive hormone. Testosterone is necessary for the development of primary and secondary sexual characters in males. The primary sexual characters are associated with a reproductive system such as the development of testis, vasa differentia and other parts, and also descending of testis into the scrotal sacs during the 8th or 9th month of development of the embryo, and enlargement of testis, penis and sperm production. These are under the control of testosterone. And if you observe the secondary sexual character features, the secondary male sexual characters that are not directly related to the reproductive system, such as voice change, that is low pitched male voice, distribution of facial and pubic hair, and masculine muscle development. These are also under the control of testosterone. So, testosterone plays a major role in the development of primary and secondary sexual characters. And come to the hormonal action on ovary. Hormonal action on female gonads. The control of reproduction in females is more complex when compared to the males. Here also, the hypothalamus that produces GnRH, how in the males, the same thing will happen in the females. As in the males, the GnR stimulates the anterior pituitary, and thereby this anterior pituitary that produces the two gonadotrophins, FSH and LH. Here FSH and LH, they interact with their target organ, that is the ovary. The FSH always it interact with the developing ovary, that is a Graafian follicle, and thereby it facilitates the growth and development of the egg or ovum. Whereas the luteinizing hormone, it facilitates the ovulation of the matured ovum. Ovulation of the matured ovum. In addition to FSH and LH, there are estrogens that are released from the developing follicle and progesterone from the corpus luteum. Whenever the ovum is developing, after the release of ovum, so the connective tissue which surrounds the egg, they produce different kinds of hormones like the progesterone and as well as the estrogens. Estrogens, that is a complex of hormones. They composed of estrone, estradiol and estriol. Here you will observe, this is the GnRH from the hypothalamus. It interacts upon the anterior pituitary that produces the FSH and LH. FSH stimulates the Graafian follicle growth, and LH that leads to the ovulation of the mature ovum. After the release of ovum from the Graafian follicle, this Graafian follicle, after the release of ovum, that modified into corpus luteum. This corpus luteum produces a particular hormone which is called as a progesterone. Progesterone shows its negative feedback on both the anterior pituitary and as well as on the hypothalamus. Thereby it stops the secretion of both FSH and LH as well as here GnRH from the hypothalamus. As and when, if the egg which is released from the Graafian follicle, if it get fertilized, the progesterone secretion will be continued up to the delivery. If at all it is not at all fertilized, then thereby it modified into corpus albicans, and that produces the estrogens. These estrogens are responsible for the secondary sexual development characters of the females. See here, the ovaries of the sexually mature females, they secrete progesterone and a mixture of estrogens. Apart from the mixture of estrogens, 17 beta estradiol is the most abundant and most potent estrogen. What is the function of the estrogens in the females? See here, estrogens are the steroids chemically. They are primarily responsible for the conversion of girls into sexually mature women. Estrogen is the reproductive hormone in females that assists in endometrial regrowth, ovulation and calcium absorption. It is also responsible for the secondary sexual characteristic features in the females. What are the secondary sexual characteristic features in the female? Are growth of breasts and nipples, broadening of hips and female body contours, increase in adipose or fat tissue, growth of uterus, vaginal lining and clitoris, development of high-pitched female voice, the appearance of pubic and axillary hair, fertility changes associated with ovarian and menstrual cycles. Estrogens also have non-reproductive effects. They antagonize the effects of the parathyroid hormone, minimizing the loss of calcium from bones and thus helping to keep bones strong. They promote blood clotting too. FSH and LH are present in both males and females, as we know. Their role is identical in both the sexes. Luteinizing hormone principally involved in the gametogenesis, that is, in the ovary it participates in ovulation and in the formation of corpus luteum. And FSH stimulates the growth of cells that support the developing of the gametes, that is Graafian follicles in the ovary. On the other hand, LH stimulates the production of sex hormones, that is estrogens in females, testosterone in males, that promote the gametogenesis. Here, the estrogens are the complex hormones which constitute estradiol, two alcohols, diol, estriol, three alcohol groups, estrone, ketone group, C11O. See here, progesterone is also the one of the hormone produced by the corpus luteum of the female. It is actually has only one goal, that is thickening of uterine walls, that is the endometrium layers of the uterus, in order to receive the fertilized egg after the ovulation has occurred, and that leads to the implantation of the developing embryo. It facilitates the developing embryo. And testosterone is actually, it is a androgen, but it is also present in the case of females, but in little proportion. That is, estrogens, progesterone, testosterone, all these hormones are present both in male and female, we should not forget, but in different proportions. That is, testosterone is present in higher concentration in the males when compared to the estrogens and progesterone, whereas in the females, estrogen and progesterone are more in percentage when compared to the testosterone, we should remember. Here you can see the biosynthesis and metabolism of estrogens and testosterone. Here, cholesterol, it is a 27 carbon component, otherwise 27 carbon compound. This cholesterol on hydrolysis divide into two fragments. One is with the 21 carbons, another with the 6 carbons. 21 carbons and the 6 carbons. The 21 carbon component is called as a pregnenolone, and the 6 carbon compound is known as a isocaproaldehyde. Isocaproaldehyde. Now this pregnenolone, it may be get modified into 17 alpha hydroxy pregnenolone and followed by dehydroepiandrosterone. Here the same pregnenolone, this may be get converted to progesterone, otherwise 17 alpha hydroxy progesterone. So here this is the androstenedione. Androstenedione and testosterone, they can mutually modify to one another like the isomers. Here the androstenedione on the catalytic activity of the aromatase enzyme, the androstenedione get converted into estrone. Androstenedione get modified into estrone under the catalytic activity of the aromatase. Otherwise, if you observe the testosterone, this also get modified into 17 beta estradiol under the activity of the aromatase. See here, you can observe here at the 17 carbon C double bond O is there, it is OH. This is only the difference in between these two, androstenedione and the testosterone. If you observe furthermore, here you can see Instead of double bond O, here one alcohol group is there, OH group, hydroxyl group. Remaining thing is same. Here there is a another OH instead of this. See here, estrone, C double bond O is there, estrone. Here estradiol, estradiol means one alcohol group, another hydroxyl, two hydroxyl groups, estradiol. See here estriol, one OH group, second OH group and third OH group, estriol, tri means three. Here di means estrone means only C double bond O. Here 1 2 diol, 1 2 3 triol. See here, testosterone get modified into estradiol, androstenedione get modified into estrone, and finally modified into estriol. That indicates that in both male and females testosterone is present, but in different proportions. If it is in the males, testosterone is kept more percentage, little amount of testosterone may be modified into estrogens, whereas in the females more amount of testosterone get modified into estrogen complex, that is estrone, estradiol and the estriol. See here, you can see the detailed structures of the estrogens. Estrone double bond O, estradiol two hydroxyl groups, estriol three hydroxyl groups. These are the structures of estrogens. Same thing here it is. Dehydroxyepiandrosterone get modified into androstenedione, finally forms the testosterone. This testosterone get modified into estradiol under the aromatase. The estradiol modified into estrone, otherwise estriol, right? Here also the dihydroepiandrosterone get modified into hydroxy dehydroepiandrosterone, and that is again modified into hydroxy androstenedione. This is also get modified into estriol. So here there is a interchange of all these structures. All these are the precursor of all these steroid hormones is the cholesterol, we should remember. All these are derived from the cholesterol, 27 carbon component cholesterol. Here you can see the difference in between estrogens and androgens. Androgens, these are the male sex hormone which promotes the development and maintenance of the male sex characters. Here the estrogens, they maintain the female characters, and androgens mainly occur in male body, estrogens in the female body. And here the best example for the androgens is the testosterone, and here it is estradiol. And other types of hormones which are related to the androgens are dihydrotestosterone and androstenedione. Here estrone and the estriol. These are all androgens produced by the testes. Here the estrogens produced by the ovaries. The androgens are responsible for the development and maintenance of the male reproductive system while developing secondary male sexual characters. Here the estrogens, they are responsible for the development and maintenance of the female reproductive system while developing the secondary female sex characters. So these are the things to be remembered. And if you observe furthermore the hormonal control of the ovarian and the menstrual cycles in the human beings, if you observe the female reproductive system, the reproductive process in women is more complicated than those in men. The female reproduction includes cyclic events in two organs. One is in the ovary, another one in the uterus. So that the entire female reproduction get divided into two cycles. One is the ovarian cycle, another one is the uterine cycle. Let us discuss one by one. Ovarian cycle. The cyclic events that occur in the ovary constitute the ovarian cycle. It includes the growth and development of follicles, that is called as the follicular phase, and release of egg from the ovary, that is ovulation, and the transformation of follicle tissue into corpus luteum, that is luteal phase. That is ovarian cycle broadly classified into three phases: follicular phase, ovulation, and the luteal phase. The cycle begins with the release of gonadotropin releasing hormone from the hypothalamus. This GnRH, gonadotropin releasing hormone, in turn stimulates the anterior pituitary gland, and that secretes the follicle stimulating hormone and as well as the luteinizing hormone. Here you will see the three phases and its explanation. Follicular phase. First one is the follicular phase, that is follicle stimulating hormone causes follicle to mature and produce estrogen, that is inhibiting the development of other follicles. That is, it starts with the release of FSH. This hormone specifically stimulates the growth of all follicles present around the maturing oocyte. But one follicle grows more prominently than the others and becomes larger. The growing follicles produce a female hormone called estrogen. The estrogen stimulates the release of luteinizing hormone from the anterior pituitary in the positive feedback loop. Positive feedback loop. Coming to the ovulation, so due to the more production of the LH, an LH surge means more production of the LH causes the ovulation, that is rupturing of the follicle and release of the secondary oocyte is the ovulation. Ovulation is triggered by the LH. It induces final maturation of the follicle, which develops an internal fluid filled cavity around the oocyte. This fluid filled follicle is called as a Graafian follicle. When luteinizing hormone concentration is high, that is nothing but the LH surge, the Graafian follicle and wall of the ovary rupture, releasing the egg. This process is nothing but the ovulation. This process is nothing but the ovulation. And coming to the luteal phase, ruptured follicle forms a corpus luteum and secretes progesterone hormone. Here in the luteal phase, it is triggered by the again LH, luteinizing hormone. This hormone stimulates the transformation of follicle tissue to a sac-like glandular structure, which is called as the corpus luteum. Corpus luteum. So here you can see the corpus luteum. See here, this is the egg. It is undergoing maturation, and here it is the release of ovum or oocyte ovulation, and it is the luteal phase. This is the yellow colored one is the corpus luteum. Because here corpus luteum is there, because of the luteinizing action, the hormone is named as the luteinizing hormone. The corpus luteum acts like the endocrine gland and produces two hormones, namely progesterone and estrogens. When concentration of these hormones rises in the blood, they inhibit the release of follicle stimulating hormone and luteinizing hormone by the negative feedback loop acting on the hypothalamus and as well as the anterior pituitary gland. Next, we see what is happening in the menstrual cycle. Later on we will discuss otherwise. Here you can see the follicular phase. GnRH is there, act upon the anterior pituitary, LH and FSH that act upon the ovarian follicles, okay, and thereby they show the development of the follicle. What happens in the follicular phase? Ovarian hormone effects. Follicles produce low levels of estradiol that inhibit GnRH secretion by the hypothalamus, keeping LH and FSH levels low. causing endometrial arteries to constrict, resulting in the menstruation. Here you can see the ovulation. Here in the ovulation, the same thing, GnRH, FSH and LH, so ovarian follicles, and thereby the ovulation takes place. Here also in the luteal phase, formation of the corpus luteum takes place. And if you come to the uterine cycle, the cyclic events that takes place in the inner lining of the uterus constitute the uterine cycle. It includes three phases, namely proliferative phase, secretory phase, and the menstrual phase. Proliferative phase, secretory phase, and the menstrual flow phase or menstrual phase. What happens in the proliferative phase? In the proliferative phase, it involves in the thickening of the endometrium due to increased rate of cell division. The thickening is associated with growth of endometrial glands and enlargement of the arteries. In this phase, the uterus prepares for the possible implantation of the embryo. This phase is stimulated by the estrogen and the progesterone hormone secreted by the corpus luteum. This is the proliferative phase. See the image? So here there is a gradual increase in the endometrium layers of the uterus. Then coming to the second phase, that is the secretory phase. In the secretory phase, what happens? The endometrial glands secrete nutritive fluid that nourishes the developing embryo. This phase is coordinated by the luteal phase of ovarian cycle. It is coordinated by the luteal phase of the ovarian cycle. And coming to the third one, menstrual phase, menstruation. This is associated with the shedding of removal of endometrium layers and bleeding through the vagina. This phase is triggered by the disintegrating corpus luteum, which stops the releasing estrogens and progesterone hormones. The drop in the levels of these two ovarian hormones causes spasms of arteries in the endometrium, leading to bleeding. At the same time, the endometrium also disintegrates and menstruation follows. The menstrual flow persists for a few days. Both ovarian and menstrual cycles stop after about 450 cycles. This is called menopause. The menopause usually occurs between the age of 46 and 54 years. In between 46 and the 54 years. See here you can see the ovarian cycle and uterine cycle glands. See here, ovarian cycle contain follicular phase, ovulation, and the luteal phase. See, this is the primary follicle, second becomes secondary follicle, vesicular follicle, and ovum is released, ovulation. And this is the corpus luteum, luteal phase, and degeneration of corpus luteum into corpus albicans. Corpus luteum produces more progesterone, whereas degenerated corpus luteum that produces more estrogens. Then you can compare this with the uterine cycle. Here, proliferative phase, secretory phase, and the menstrual phase. So here you can see at the day of 14 after the menstruation, there is a release of ovum, ovulation. If you start with the day 1, here the proliferation stage in between 5 to 13 days, and here ovulation takes place. After ovulation, the endometrium layers get developed more in order to implant the fertilized egg, and here there is a secretion of nutritive fluids to thickening of the endometrium layers. Okay, if at all there is no implantation at all at the day 28, slowly due to the menstrual flow, the endometrium layers get ruptured and the bleeding occurs through the vagina. So here you can observe both the cycles at a time, ovarian cycle and the uterine cycles. So this is the follicular phase, then this is the ovulation and the proliferative stage and the secretory phase. Like this we can compare. Otherwise here you can see this is the ovarian cycle and this is the uterine cycle. Let us see the hormones. Let us see the hormones. See here, the during the ovulation there is a luteinizing hormone surge, LH surge, and follicle stimulating hormone is somewhat less, right? And if you observe, estradiol is more slowly dropped, okay, during the ovulation. If you observe the ovulation and the changes in this direction, in the sense of body temperature, okay, hormones, then estradiol and progesterone, right? If you come to the luteal phase, here there is a FSH and LH, they are decreased, whereas the progesterone is increased, okay. Thereby here there is a gradual development of the endometrium layers. Then furthermore, if estrogen progesterone is dropped, then here menses occur in this stage. This is nothing but the menstrual cycle. Here there we can see both the cycles at a time, ovarian cycle and the uterine cycle, and the respective factors. Broadly, the events of ovarian and menstrual cycles are repeated every 28 days. On the average, one mature ovum is released from one of the two ovaries during this period. While describing menstrual cycle, it is common practice to place ovulation at the mid of the cycle, that is on the 14th day, and the first day on the start of menstrual flow. The whole process, that is ovarian and the uterine cycles, they are divided into three phases, namely proliferative phase or pre-ovulatory phase. Second one, ovulation or ovulatory phase. And third one, secretory phase or post-ovulatory phase. Let us start with the first one, proliferative or pre-ovulatory phase. This takes place 1 to 14 days. 1 to 14 days. It starts from the day of menstrual flow. During this phase, the follicles grow and produce estrogens, which cause the formation of new endometrium in the uterus. And ovulation phase on day 14th. During this phase, the luteinizing hormone levels rises rapidly in the blood. The luteinizing hormone stimulates the bursting of Graafian follicle and the release of ovum from the ovary. That is nothing but the ovulation. On the day of ovulation, the body temperature rises by 1 degree Fahrenheit. 1 degree Fahrenheit. And come to the third one, secretory phase or post-ovulatory phase. This is from day 15 to day 28. Day 15 to day 28. In this phase, the ruptured Graafian follicle becomes corpus luteum and secretes estrogens and progesterone. The progesterone stimulates growth of blood vessels and proliferation of cells in the endometrium and accumulation of glycogen. It also helps in the final preparation of uterus for the reception of zygote. So these are the broad classification of the entire female reproduction. So both the cycles, ovarian cycle and the uterine cycle. If at all fertilization takes place and the zygote is implanted in the endometrium of uterus, progesterone maintains the endometrium throughout the pregnancy. This function is shared by the progesterone secreted by three different endocrine tissues. Initially, the progesterone secreted by the corpus luteum. This corpus luteum takes the charge for the production of the progesterone, After its disintegration, the second one is the extra embryonic chorionic tissue that secretes the human chorionic gonadotrophin HCG, human chorionic gonadotrophin, which maintain the endometrium for about 3 months during the pregnancy. During this period, small amount of human chorionic gonadotrophin is excreted in urine, which forms the basis for the pregnancy test. So, if you take a preg kit, dip in the pregnancy women's urine, and you can find out the result whether they are pregnant or not. So, pregnancy confirmation test is due to the presence of human chorionic gonadotrophin (HCG) hormone in the urine of the pregnant women. In the last stage, the placenta takes charge of the production of the progesterone. The placenta secretes progesterone, which maintains pregnancy till the delivery of the child. Here, in order to produce continuously the progesterone, there are three factors. First one is the corpus luteum, second one is the extra embryonic chorionic tissue, and third one is the placenta. They play a major role in the continuation of the production of the progesterone. Here you can see the hormone factors of the male and female. In the women, more estrogen; in the male, more testosterone. In the female, less testosterone, but in the male, less estrogen. The stopping of the ovulation is called as the menopause. Stopping of the spermatogenesis is called as the andropause in the male. Menopause in the female, andropause in the male. Finally, menstrual cycle versus the estrous cycle. Menstrual cycle generally, if we take into consideration the mammals, these two are the different reproductive cycles occurs in the female mammals. In humans and other primates, the reproductive cycle is called as a menstrual cycle, whereas in other animals, in other mammals rather than the primates, humans, that is known as the estrous cycle. In both these events, ovulation occurs at a specific time during the cycle. It is associated with the thickening of the endometrium and development of the rich blood supply with a view to prepare uterus for possible implantation. The menstrual and estrous cycle differ in the fate of the endometrium if the implantation does not take place. What happens in the menstrual cycle? In menstrual cycle, the endometrium is shed from the uterus through the vagina in a bleeding condition called menstruation. But in the estrous cycle, the endometrium is reabsorbed into the uterus and hence extensive bleeding does not occur. This is the main difference. In the case of menstrual cycle, there is a burst of the shedding of the endometrium layer from the uterus and bleeding occurs through the vagina. It is called as a menstruation. In the estrous cycle, the endometrium layer is get reabsorbed into the uterus so that there is no external bleeding at all. Then the human menstrual cycle is repeated every 28 days, but estrous cycle differs in its frequency. It is 5 days in rats, 1 year in dogs, bears, and the cattle, and several years in the elephants. Human females are receptive to sexual activity throughout the period of the menstrual cycle, but most other mammals show sexual activity during the estrus. Estrus means frenzy or passion or heat period, and copulate only during estrus but not throughout the year. This is also another more important difference. Here you can see menstrual cycle occurs in primates, monkeys, apes, and human beings only. It occurs in non-primates such as cows, sheep, rat, deer, dogs, tigers. Menstrual cycle consists of menstrual phase, proliferative phase, and the secretory phase. It consists of short period of estrus or heat. Blood flows in this cycle, blood does not flow in this cycle. These are the certain differences. See here the average reproductive cycles of the cow. Here, length of the estrous cycle is 21 days. The gestation period is 282 days. Eve 17 days, 148 days. So 21 days, 115 days. Mare, that is a female horse, 21 days and the 335 days. Here, length of estrus may be different in different animals. See here, you can see the estrous cycle of dogs. Let us assume usually of about 7 to 9 months it is 7 to 9 months it is non-fertile stage, unestrus, no bleeding, resting stage until female comes into heat again. Proestrus 9 to 10 days, non-fertile stage. Bloody discharge can occur or not, varies in color and intensity among individuals. Estrus stage is only 5 to 9 days, ovulation and fertile phase. Discharge often becomes pinkish red but can also stop at this point. While females remains most fertile, female becomes receptive to males. Then diestress 2 months, non-fertile stage. Bloody discharge can occur or not and stop eventually, varies in color and intensity among individuals. So throughout the year, dog shows 5 to 9 days it is fertile for the reception. So during this phase, ovulation takes place and pregnancy occur. So this is all about the hormones of the male and female. Thank you.